Hello, everybody. I think before we get going, I just want a raise of hands. Who in here knows about Blazor already? And how many of you are building Blazor applications? So about the same amount. Okay, good. So yeah, before we get started, I just want to say that I'm not going to introduce you to Blazor at all. So it's good that most of you already know what's going on with that and testing for that matter. I'm not going to talk do an introduction level on that. So this is just going to be us deep diving into maintainable Blazor components and how to make them testable as well. And I cheated. I started a bit early, but let's get started. So let me start by introducing myself. My name is Egil, and as you can probably hear from my accent, I'm Danish. I do live in Iceland, and from there I work remotely for a Danish company called Delegate, and I'm also Microsoft MVP, and I became an MVP because I created bUnit. bUnit is a testing library for Blazor, which we will talk about a little bit later. And once in a while, I'll also jump onto Twitch and do some live coding. So if you like what you see here today and want to come hang out and build open source with me, that's a possibility. It's not weekly these days, but it is something I want to get back to. And you can reach out to me on Twitter, and feel free to just add me on Twitter if you have any questions now or in the future. Okay, so let's get going. But before we do, I just want to align expectations a little bit. I'm not the first person to stand on a stage and talk about maintainable codes. Frankly, I'm standing on the shoulder of giants here. Many people have come before me. So from a pure code perspective, I'm not going to teach you anything new necessarily. I'm not going to reinvent any wheels. But I will highlight the good ideas that I use in my everyday when I'm building Blazor components and show how I apply those general good coding practices to Blazor components. So one such person that has definitely stood on the stage before me is Dan North. And a couple of years ago, he formulated the qubit coding properties. And I like them, and you can go and read about them on the website. But he did one thing I want to highlight. He chose to call them properties instead of principles. And this is the reason he gave. So he says, principles are like rules. You are either compliant or you're not. So this gives rise to a bounded set of rule followers and rule enforcers rather than a centered set of people with shared values. Instead, I started thinking about properties, qualities, and characteristics of code rather than rules to follow. Properties define a goal or center to move towards. Your code is only closer to or further from the center, and it's always sort of a clear direction of travel. So this speaks to me because I don't always write super maintainable code, and I don't expect you to do so either. Sometimes hacking something together quickly is faster, and especially I think when you are sort of in uncharted territories, working on something you haven't worked on before. At least that's how it works for me. So with properties instead of principles, I don't have to feel bad when I don't sort of hit the high goal of really maintainable, clean codes. But I do try to be deliberate about it, decide when I need to, write code that needs to, stand the test of time, or when I can move away from the center, as Dan puts it. So, what is maintainable code and what is testable code? So, if you look at what it means to write Blazor components that are both maintainable and testable. So, in my experience, I guess with regular code as well with Blazor code is that if you have code that is testable, it also tends to be quite maintainable. It is obviously possible to write maintainable code that is not necessarily super testable. So if you do want to test your Blazor components or your code in general, I tend to recommend using test-driven development approach. Maintainability and doing that is not obviously, it's not necessary to write, it's not necessary you follow TDD to write maintainable code, but in my experience, it does help land you sort of in a pit of success because testability usually also means things are quite maintainable. But we'll get back to testing a little bit later. First, I want to focus on maintainability. So, if we start at a higher level, we can get some inspiration from Mark Seaman. And let me step out of the way so you can look at his pretty face there. He wrote an excellent book recently called Code That Fits in Your Head. And in there, he talks about maintainable code as code that follows a fractal architecture, as he calls it, where each layer of the fractal has up to about 7 things. And if you want to understand more about an individual thing in that fractal? Well, you can double-click or zoom into that next layer, and that reveals another layer in that architecture with another up to 7 things that is just on a lower level of abstraction. So you can ask, why 7? Well, research seems to suggest that the average person, the average human, can keep track of about 7 things at the same time. And I guess us developers, we can sometimes feel like we're not average, but still I think it makes sense to have that rule of thumb and apply that to the code we write so that our code is easy to understand and maintain over time. Now, I think an added bonus of this metaphor of a fractal is that it translates quite well over to the concept of Blazor components. Like standard Blazor application would typically have an app component as its entry point with maybe like high-level stuff like routing and authentication at the top level. Then we go one level deep. We have maybe layout stuff. Then one layer deep again, we have pages. And then one layer deeper again, we have what the components that make up the pages themselves. So that metaphor of going up and down a fractal sort of translates well, I think, to Blazor components as well. I think the key takeaway here is that we have to not do too many things at each layer in our applications, and basically keep that around the number 7, the number of things that happens at each layer. So when we go to the component level and look at the properties for maintainable components, if we want to create components that can fit in our head, so these are the properties I sort of tend to go to when I want to do that, and it basically applies to just C# code and general code in general. So I think the first thing, you probably heard this before, is that a component should do one thing well. But what does that mean in practice? How can we sort of understand and make sure that our components just do one thing? Well, one of the indicators is that they don't mix abstraction levels. So if we use Mark's terminology, that would be a mix of different levels of the fractal in the same components. They also exhibit high cohesion, and I'll get back to what that means a little bit later. And they don't depend on infrastructure. They depend on abstractions. Like we don't use things like HTTP client directly in a component. We have an abstraction that we can represent that thing of talking to a service, for example, or DB context, and that also improves testability quite a bit. And finally, of course, they have good names. Like everything, naming is the hardest part of programming, and our components also need good names to sort of give them context. So following these principles makes it easy to understand a component in isolation and comprehend what it's supposed to do without sort of having to understand all the use cases it might be used in. So you can sort of look at a component in isolation. It also makes it easier to write tests for it and test that thing in isolation. And the thing that actually, this works quite well for Blazor because Blazor components compose very easily together. So we have things like event callbacks and parameters and scaling parameters and being able to put multiple different components into other components. So we get that composability, and that means following these properties, and try to call it properties, learn from Dan North here, that becomes quite easy, and actually we don't have to fight the framework, which is a good thing. So let's look at an example on how this looks in practice. So for example, I've created this simple data table component, and it works by you basically pass it a collection of objects, and it will figure out what rows and columns to render. So in this case, we're passing in a bunch of movies, and we get a table head out with columns based on the public properties of the movies, and we get rows for each of the movies. So let's look at the implementation of this and see how we can maybe refactor that to be more maintainable now. First, we need some magic, and the magic comes from the system reflection namespace, and we need a type param. And okay, it's cut off down here, but it's fine up there, so that's good. Okay, the type param is going to represent the T item that we will render out in our data table. Once we have that, we need a parameter that we can pass items into. And after we have that, we need some help. We need that items property info property we have here, which is going to use reflection to get all the public instance properties of our T item that we can actually read. Once we have that, well, we need a helper method that will pull out the names that we're going to use in our columns. So we have a getColumnNames method here. And Finally, we have get items data, which is a method that will take an item as input, and it will use the property info we have about each of the properties of that item and pull out the data in that property. So if we scroll down a bit, we can look at the markup we actually want to create. So first, we'll have a table, obviously, and then inside that, we'll have a table head, and that table head will print out a row containing all the column names that we get from the get column names method we created above. And then underneath that, we'll have a table body, and we can for each over each of the items. And then for each item, we will call the get items data method, and that will give us each of the public properties data in an individual item, and we can print that out as a table. So, how can this data table be simplified to be more maintainable and testable? And you might actually say, well, it's quite simple already. What's the point here? And normally, unless I was standing on a stage, I would probably agree and say we're pretty much done here. But let's, for the sake of demonstration, try to see if we can refactor it a little bit and make it even more testable and maintainable. And you could also imagine that if you're actually in a real business scenario and you might have a manager will come and say, well, can we also add some sorting and filtering and inline editing and all sorts of good stuff that you normally have in a full-blown data table component, and all of a sudden our 30 lines of components is going to grow quite a lot, and maybe maintainability will start taking a turn for the worse. So one of the things we can do to sort of get an idea of where we want to go with our refactoring is to look at the sort of code smells we talked about before. And one thing is the mix of abstraction levels. So we do actually have a mix of abstraction levels in this component. At a higher level, we are dealing with the plural, the multiple items. That is sort of what the red parts, as I've sort of tried to illustrate that visually here. These part of the table is about putting out the multiples of items, whereas the blue parts here, they are dealing with the individual item. That's sort of a lower level. They're just concerned about one single item at the time. So that's sort of an indication that there is sort of a mix of abstraction levels here. We could also take a look at it from the point of cohesion. So high cohesion in just a regular C# object could be, for example, if you have a C# object for two methods, and one of the methods uses half of the private fields in that class, and the other method uses the other half of those private fields in that class. So that's sort of an indication that we can take one method and half of the fields and put them into another class, and the rest of the class would not care because there's no dependency between them. So that's sort of an example of low cohesion. And we can look here and see we actually do have conflicts with high cohesion, low cohesion. So in this case, we have the part that is dealing with rendering out the header of the table. That's one part, and then we have the blue part here, which is about the items. They don't really have a dependency on each other, and they can easily be pulled out and moved to different classes without actually, different components, without actually causing any problems. So let's attempt a refactor here. I think first, let's move the helper property out that deals with the magic of figuring out what the components of the item structure is, and move it into a helper class. And that looks like this. So now we just have a static helper method with a get items property info method now that we can call to get the details about the T item. Now we are ready to sort of start splitting things up a bit more. So let's start by moving the header part out into its own component, and you probably guessed it's going to be named data table header, and it only needs to know about the type of the item that it's going to be rendering columns for, and it looks like this. So here we have a nice, highly cohesive, very focused component that is, if you come back to it a year later, you should be able to pick up pretty quickly what is actually going on here. And the next part, you probably guessed that already. Let's move out the data part here, the thing that renders out rows, and move that into a data table row component. And it will take the individual item as input because it's just working on that part. And here we see the data table row component. Again, simple, easy to understand component. Now, this is the final sort of refactored component. And again, the key takeaway here is that we've sort of slimmed this down to really only do that one thing well. And this is the same thing you probably already do when you're creating just regular C# code, trying to aim for that sort of simple classes that are easy to understand and easy to maintain. I think sometimes, though, that with Blazor components, it can be a bit too easy to just add another blob of markup into a component. And all of a sudden, that component grows and grows and grows, and you're sitting there trying to figure out which part of the markup is actually responsible for that UI glitch you have up in the front end, and you can't quite maybe figure out which part of the backend code supports the markup. So I really like to utilize the composability we have with Blazor components and move related sections from markup as we did right now, and the code that drives those sections into subcomponents. Even if those subcomponents are only going to be used by one parent component, I think that's fine, because it's just so effective, and it makes it much easier to understand what a single component is going to be doing. We did skimp over the don't depend on infrastructure bit, and the example there, of course, is the typical HTTP client you would have in your Blazor component, or maybe a DB context. And I think it's generally a good idea to move those into an abstraction, move it behind an interface, and then create a complete implementation that deals with authentication and calling that API and caching, all of that stuff. So you move that out of your component. It's sort of a different concern, and that also improves testability quite a bit. So now we talked about maintainability and just applying the good patterns we already sort of remember and know for our C# code. Remember to apply them to Blazor as well. So let's jump into testing. And for testing, we are going to use bUnit. And the first thing we can talk about is what is bUnit and why do I need it? So bUnit is a testing library for Blazor components. It's not a testing framework like XUnit and NUnit or MSTest. It's a library that you add on top of your test project, like XUnit, for example, like you would with fluent assertions or NSubstitute or Hibernate or whatever is your favorite testing library. So it's just a library we add on top of that enables us to test Blazor components. That also means that your tests are going to feel and look and behave sort of like your regular C# tests. And you will be able to reuse all the patterns and practices that you've established in your team and in your organization or in your own code, and you can sort of use bUnit to write tests in the same way that you would write and test regular C# objects. So one thing that bUnit doesn't do, which is perhaps different from other UI testing frameworks you've used before, is it isn't like Selenium or similar, where it actually spins up a browser and renders the full Blazor application up there and interacts with the UI and renders with JavaScript and CSS and everything, and then instruments that. bUnit runs entirely in C#, and that also means it doesn't run your JavaScript. So if you have any JavaScript yet your components are calling into, it won't have that part with it. bUnit does come with a test-specific IDS runtime implementation that allows you to emulate that call to JavaScript, set up expectations, much like you do when you're doing mocking of an interface. And if you do want to have that full end-to-end test experience with the CSS and the HTML and the JavaScript and the component together, I do recommend looking at something like Playwright from Microsoft, which is, I guess, a modern version of Selenium for getting that experience. But the advantage of bUnit and that it doesn't run your JavaScript, doesn't instrument a browser and run that in the background, is that it runs fast, and we have big, deep ties into the Blazor runtime, so we can understand what's going on, and we can speed things up, and we can sort of make it easier to make this test stable and predictable. It's not a black box like it is when you're running in a browser. So, the next question you might ask is, why is bUnit, or why is bUnit necessary? And so, when we are writing tests for our component, we want them to be treated the same way they're going to be treated in a production system, in a production environment, in a Blazor runtime. And that means we want them to have their lifecycle methods invoked in the same manner that they're going to be invoked in the real world. We also want parameters and services to be injected in at the right time and the right way. We want have to remember to move a bit. We also want the components that have event handlers, we also want them to be invoked in the same way as they do when you click a button in the browser window and things happen in the Blazor code. And I think most importantly is that components actually don't know how to produce markup. They have this abstract representation of the markup that you want them to produce, and then we have a Blazor renderer that comes in and looks at that render tree and turns that into HTML elements into a DOM object model. And I guess, so bUnit is basically a Blazor runtime that builds on the native runtime in Blazor, but specifically designed for testing purposes. So how do we actually start using bUnit? Well, here I have a standard CS proj, .NET 6, .NET 7 will work fine as well, for an XUnit test project. And the only thing we need to do is, well, we need to change the SDK type to Microsoft.NET.SDK.Razor, because that will enable the Blazor compiler to run in that project, and we would want to write our unit tests in Razor files. That gives us some advantages we'll get back to later. And obviously we need to include the bUnit package. Now that we have a test project, we can also write a test, and we have to have something to test. We can use the counter component, and I guess you all know that if you've been a little bit of Blazor. In case you don't know how it works, you have a counter and you have a button, and when you click the button, the counter increments. So how can we write a test for that? So first, let's create a countertest.razor component file, and in there, in the code section, we can create a test, XUnit fact called counter should increment when clicked. And the first thing we need in here is a test context. Test context is the bUnit thing, and it's the thing that allows us to render a component. So when we have that, we can render our counter component, and out of that we get a rendered fragment. The rendered fragment is sort of a representation of that rendered component. It gives us access to the component tree that was created by rendering the counter component. It gives us access to the DOM object model and the rendered markup, and allows us to interact with the component and get to the instance of the component as well. So now that we have the counter, well, we want to find that button and we want to click the button. So we do that by using the find method. The find method takes a CSS selector, and so we just pass in, we want to find the button, and once we have the button, we call the click method. And the click methods, well, that will trigger the event handler bound to the button in our Razor component. And once we've done that, well, we can write our assertion. Our assertion will be to go and find the paragraph element, and then use this is a special assertion method in bUnit called markup matches that will verify that the paragraph has markup equal to what we see here. That is, that the current count is now 1 instead. So this kind of looks very much like a regular unit test. The only thing that is slightly different is that we are sort of going through and accessing the component through the test context and the rendered fragment we get out of that. Now, you might have noticed this and think that doesn't look like legal C#, and it actually is. It's because we are in a Razor file, and so the Razor file is quite magical that they can do this. But we start out actually up at the very top. We start out sort of in markup mode, and then we enter into code mode where it's just regular C#. But we can actually escape out to markup mode again just by adding this @ sign. And that will basically allow us to write markup directly in our C# code, which is quite convenient when we want to configure and set up a component under test with parameters and so on and so forth. We can just do that like we do regular in Blazor. And also, for example, like in this case where we want to set up an expected markup, we can just specify that, and we get syntax highlighting, auto intelligence, completion, everything directly in our C# code for our markup. That's pretty impressive that they can do that. So running a bUnit test, well, I have to remember not to stand over here, so I'm blocking the screen. Well, it's just an XUnit project, right? So anywhere you can run an XUnit project or MS test or NUnit project, you can. So in this case, we're just using .NET test, and with a little bit of extra logger sprinkled on top of that, so we can actually get some output, and you run the test, and you'll see everything is green, and we are happy, right? So now that we have a bUnit test project or XUnit project with bUnit on top of that, the next question we might want to discuss is, what do we actually want to test? And you can sort of verify the markup a bit like we did here, or we can focus on functionality. So in functionality testing, I sort of define that as where we just poke at the component, we try to interact with buttons or form fields and trigger event handlers, and then we observe something that changes, like state somewhere else, maybe in the component, maybe external to the component. So if we take a look at functionality testing first, well, our data table component didn't have a lot of interactivity about it. So I've stolen this dialog from the Blazing Pizza workshop, and you can find links to it here if you want to sort of get up to speed with Blazor. That's a great workshop. In this case, you have to imagine that we are in a pizza shop, and we've selected the buffalo chicken pizza, I guess, and we want to add some extra toppings to it. So this is basically the functionality we want to test. Now, if we look at the tests, that would look like something like this. So test is selecting topping from drop down, adds it to pizza. So how does that work? Well, first we need a test context, we need a pizza, and then we can render our configure pizza dialog components and pass in the pizza to it. And once we've done that, well, our task is to go and find the drop down we saw before and select just any element in there. We're just going to pick the first one. And once we've done that, our assertion can be that now the pizza's toppings collection should no longer be empty, right? So there's many ways to go about it. The important bit here is we have very little sort of coupling to the actual markup that the configure pizza dialog component produced. So that this test should not break if we go and change a bunch of things about the markup. It should only break if the sort of core functionality of us selecting a new pizza topping, if that doesn't show up in the toppings collection of the pizza, well, there's something that's wrong there. So this is about creating maintainable tests that doesn't break when things change around the system under test that isn't sort of directly related to the test at hand. So that is sort of just, we have very little tie. We have a little bit of tie into the markup, but we could even make that more simple. But that is sort of where I sort of say, well, this is focused on the functionality and not on the markup itself. But sometimes you do want to verify the markup, and when you do, you should probably do that semantically. So semantic verification is something I define as when two pieces of markup behave the same, look the same, and sort of have the same behavior in the browser from an end user perspective. And as you probably know, the browser is quite forgiving. You can have multiple white space characters next to each other in a browser, and it will be rendered as a single white space. So if you do a comparison just using regular string-based comparison, like you do with an assert equals, for example, with two strings, well, that assertion is going to break as soon as you make a slight small change that won't look any different to the end user in the browser, but it will break your test. And that's, especially when you're dealing with markup, that you can move that around quite a bit to make it more readable in your editor without breaking things in the browser. Well, you don't want your test to break because we're changing things that doesn't really influence the end result, what the user will be seeing. So bUnit does have a semantic compare built into it, and that is what we're using. So let me show you how to do that. So here we have a very simple component we can use as a demo example here. And this is the test for that component. So you will notice that the markup matches method, this is the secret source, this is the semantic compare built into bUnit. You can also, by the way, just a small side note, if you want to, you can also just get that and use it outside of bUnit. It's part of AngleSharp and AngleSharp ecosystem, something I created sort of as a side thing to bUnit. But enough of that. Anyway, the markup matches method, right now we're just passing in the same markup as we have both in the component and in the test. But if we go ahead and reformat the component, well, markup matches is going to notice that these two are semantically the same. They're going to look the same in the browser, so it doesn't matter. So the test will still go green. We can change the order of attributes. The test will still go green because that doesn't matter to the browser, so it shouldn't matter to our test. We can even go ahead and change the order of the classes in the class attribute, and the test will still go green because it's still the same markup to the browser, to the end user. There are a bunch of other things that we can change, and it will sort of know that. It will also know if you have a pre-tag, for example, where the white space actually does matter, then it will sort of enforce the white space and do correctly handle that as well. So another thing we can do is we can add, I haven't found a good name for it yet, so I call it modifiers or semantic modifiers. But for example, if you have something like an ID attribute where the content of that attribute is generated every test run or every run, maybe it's based on the GUID or something like that, well, it's going to be hard to create a stable test. Well, we can actually add something like, for example, the regex modifier here and tell to, instead of using string-based comparison of the content of the ID attribute, use this regular expression instead. So that allows you again to create more stable tests based on your markup that is being produced. You can also say, well, this button here, well, not in this case, but if we imagine this button actually belongs to a different component or subcomponent, well, we can just tell the markup matches to ignore the component and everything that is below that in the tree, not the component, sorry, the element, and then it won't be part of the test, so we can change that button and all of its sub-elements without breaking that test. So there's a whole bunch of modifiers we can apply as well to create stable tests that do verify the markup without breaking tests necessarily. So, creating maintainable tests, how does that look? Well, I like to avoid duplicated code within my test classes. I don't necessarily want to avoid it between test classes because I want to keep them independent of each other. But within a test class, I want to avoid duplicated code. And how do we get there? Well, we try to move common arranged code and infrastructure code, not infrastructure, but a common arranged code like you see in every test, move that into constructors or setup methods that depending on the test framework you're using. It could also be using creational patterns or libraries for helping creating test input data. I tend to favor something like Bogus or Autofixer to help generate my test data so things are more natural, or create helper methods, create factory method that uses the domain language to make it easier to read and understand what's going on in a test. For Blazor-specific tests, I try to only verify the markup that it actually belongs to the component that is being tested right now. And I try to stick to one logical assertion per test. And I don't mean one assertion statement, but one sort of group of assertion statements together that forms one logical assertion about the business thing that we are testing right now. And if I see sort of a pattern of the logical assertions that goes again and again and again, I will try to combine those into sort of helper methods, again using domain language so the test is easy to read. So if we apply these concepts, ideas to testing our data table component, it could look a bit like this. So the first thing we can do is, instead of having to new up our test context every time we have to create a test, we can just have our test component inherit from that test context, which means it becomes a test context, and all the methods on that is readily available in our test component. So the first test could be something very simple, where we just want to verify that the markup produced by the data table component is actually what it's supposed to be. So we just render the data table component without any input and just with an object's t item. And then we can assert that the markup that the data table component is responsible for actually is the right thing. And we use that ignore children to say, well, everything under the table head, t-head element, that belongs to the data table header component, so I don't want that to be part of my test here. Now, we can also write a data table, uses data table header to render the data table head bits to verify that the data table component is using the data table header component correctly to render out the header. And we do that by going in our test into the component tree using the find component method, and that will tell bUnit to go and find a child component of type data table header underneath the data table component. And now we can assert that, well, we can go and find the t-head component of our data table component, and we can say all of its child nodes should match what the data table header component is producing. So that's sort of a way for us to verify. There's many ways you can go about this, but that's one way to verify that the data table header component exists in the right spot in our data table component. Now, what if we want to verify that the data table uses data table rows correctly? Well, for that, we're going to need some input data, so I'm going to pass in 2 movies to the data table component. And again, we're going to go in here to the data table component and search for all the data table rows that have been added to the component tree underneath the data table component. And that gives us a collection of data table row components. And then we can go and extract all the movies that were passed, all the individual movie items that were passed to the data table row component by going into each of the data table rows and going into the instance and looking at the items property. Now we have a collection of movies that were actually passed to the data table row components in our component tree. And now it's a simple matter of asserting that the items, the movies in the rows, they are actually equal to the original movies. So now we sort of verified that the composition of the data table and the data table rows are right without actually tying them too hard together, those tests. So I'm going to skip showing you a test for the data table header component because it's going to look much like the data table row tests here. But we can just do a simple sort of basic test and say, well, if there's no item being passed to the data row, it's just an empty column. It's not a super interesting empty row. Sorry, it's not a super interesting test, but it's something that you might want to have there. And then we can write a simple, again, test that verifies that a data table row renders columns based on the public instance properties of the t item it's passed. And it looks quite simple. It looks like this. We create a movie item and we pass that to the data table row, and then we can assert the markup should match a specific structure. So let's summarize. The idea here is that we tested the components and the markup they produce individually and independently of each other. So we don't have test breaking when sub-child components markup changes, for example. And another thing we did, we verified how the components are composed together, how they're using each other, what parameters they're passing to each other, so that we know we are using them correctly and tying them together correctly. And I'm a little bit out of time, so let's quickly summarize. Well, we talked about techniques for maintaining components. I gave you an intro to bUnit and techniques for maintaining maintainable tests. And with that, I'm going to say thank you very much for attending and showing up. And here's my links for the various social things. You can reach out to me. And a brief shout out to some sponsors I have that has been sponsoring my work in open source. If you have the ability, go back to your boss, or if you are the boss, think about sponsoring some of the open source projects that you might be using in your code bases. I can say, from personal experience, it does keep the motivation going, does help to get that sponsorship from users. It really sort of keeps the open source ecosystem alive. So I'll leave you with that and say thank you very much and hope you have a great rest of the conference. And if you have any questions, come up here and talk to me. And that's going to be it.